Alright, Harmony Science Academy. Math students, we're going to be really focused on mastering critical skills, okay, for the start and to end your 6th grade career, okay? So, let me kind of adjust this here real quick. Okay. So, you guys will be working on 25 of these skills, okay, and hopefully by the end of this week you'll be that much better and that much faster at these, okay? So, can you graph an inequality? Okay. Well, when it's written in this form, n less than -5, you want to come back here and replace n, okay, because it's by itself, it's ready to go, and it'll help you to say this: all numbers less than -5. So when you say that, okay, you know here's -5 and all the numbers less than, okay? Now, what else do you need to know for a problem like this? Okay. Closed circle is for this symbol, okay, and actually even an equal, okay. Open circle, see how this is an open circle? It's for these inequalities not equal, okay. So that's important, and because all numbers less than are to the left, that's what you highlight, okay. So open circle this way. All right. Let's see here. I can solve and graph an inequality, okay? So here, we don't have the variable by itself, okay? Which is okay. So what I'm going to do is I'm going to copy the inequality. Alright, the first thing you're supposed to do by now, after our training, is you want to identify the center of the equation or the inequality. You want to say everything, if this is the center, right, the inequality, the equal sign, whatever, this over here is the left side, and everything on this side is the right side, okay? Now, if you look at your notes, you want to look at the operation, okay, which is plus, so that should tell you to do the opposite. Okay, so that's going to allow us to have x. Okay. Alright, so I'm going to graph this. However, I'm noticing that this is a 35 and I wrote a 15. Okay, so let me squeeze in the 35 here. Oops. Now 35 minus 18 is 17. Okay. Now that I'm here, okay, I definitely want to take the opportunity to read x greater than or equal to -17. Okay. Excuse me, 17. Okay, positive. But also remember that little trick. Any number bigger than or equal to 17. So any number bigger. Okay. So let's go to 17. Here's the equal, so I'm going to close it. And any number bigger, so I go this way, because these are bigger. Okay? Alright. Let's now go to 3 less than 11. Okay. Now this one, typically in math, okay, this means when you guys are trained to go left to right, good. Okay, this is one of those special moments. This is special. Okay, you have to put a star for this situation. Now, less than, okay, this doesn't say 3 is less than 11. Okay? because this one you would read it like this: 3 is less than 11. How do you know? Because is, right? Is, again, this is a special situation, is equals. So 3 is less than, okay, 11. So this phrase right here, is less than, is very important with the word is. Okay. Now this one says 3 less than. Okay, so a lot of you guys would consider an option like this. Okay. 3 is less than 7. So a lot of you guys would consider. So by the way, this one is wrong. Okay. Let's talk about another one that is also wrong. Okay. So 3 less than 11 is different than 3 is less than 11. Okay. A lot of you guys go from here to that, wrong. A lot of you guys would go to this other wrong, which is 3 minus 11. Okay. So we can actually spend time in class talking about this one, but here's the bottom line. It's this. Okay. So imagine that somebody gets paid $11 and another person gets paid 3 less than 11. That would be 8, right? 11 minus 3 is 8. This one here would give us negative 8, something different. Okay. So again, just put a star, special scenario, this right here. Less than. Okay. This one. It's just a very special case in math. It pops up in a lot of tests because they know students can easily get that wrong. Okay? Alright. Now let's go over here. I can solve with equations. So here we have an equation. And once again, identify the center. Everything on this side is left. Over here is right. Now we can do the opposite operation, right? But I need the operation. A lot of you guys will see the negative 10 and put a plus 10. That's wrong. Okay? Careful. So negative 10 is the number. You have to look for the operation. And when it's not jumping out at you, it's a lot of times invisible multiplication. Okay? It's not imaginary. It is there, but it's invisible. So then you would do the opposite. Divide by negative 10. It cancels. Okay? Alright. Let's see here. For number 5, 4 workers are hired to seed a field. Each is given a plot, which is 6 by 11 meter in size. What is the total area? Okay. These area prompts, if they give you a drawing, an illustration, great. If not, get your pencil and draw it out for you. Okay. So 4 workers, each given a plot. Okay. So we've got something like this. Right. Okay, and this one is from here to here, it's about 6. From here to here, it's 11. Okay. What is the total area? So again, maybe I'm going so fast for some of you guys, but the main thing is draw it out so you can see it. Okay. Draw something that matches the story. So, what is the total area? So the area of a rectangle is base times height, right? Of a rectangle. So that would be 6 times 11. Okay. So that gives me this. But I've got another 3, right, or 4 total. So then I can multiply by 4 and get my 264. Okay? Which you could do give me these guys as well. Alright? Let's go and continue. I can evaluate expressions. Okay? And just so I don't forget, notice how this says I can simplify expressions, I can simplify exponents. So let's talk about evaluate and simplify. Okay? Like everything, understanding the language, words is very important. So these are about the same thing. Okay, so why do we need different words? Well, notice something. E value, you expect a value, right? Some kind of number. Simplify means we can't get the value. Okay, there's probably an unknown, right? A variable we just don't know enough about, but we've made it simpler. Okay, so both of them make it simpler, but evaluate lets you go a little further. Okay, just something to think about. So anyways, let's go ahead and start with this one. So we have PEMDAS. Okay. Right, this is how we are now. Right. Referring to PEMDAS, right? We've got M and D, which is done at the same time. What matters is who's first, left to right. Same thing with addition and subtraction. We put not an arrow here, but a dot, okay, a point, because we start left and go right. We don't go left and right both ways, just this way. Okay. All right. So let's see here. If I'm going to look at this problem, give me 1 second. Okay. I am going to go ahead and look at parentheses first. Now there's a whole bunch of parentheses. Something to keep in mind is when you open, okay, a parenthesis. I've opened 1, 2, close 1, 2. Open 1, close 1. Okay. So you can count how many times that it's been opened, and you expect to close them somewhere along the way. Otherwise, there's a problem. So anyways, when it comes to so many parentheses, you can always go to the one furthest inside, which is this one, okay? So I'm going to have 8 minus 4. Now that I've done this, okay, notice what happened here. Open, open, close 1. I don't have another close. Okay, over here I was about to open, but I have to be like, hey, before I can open another, I should have closed the ones I opened. Okay. Now, since I'm done here, I'm going to squeeze in another step, just because this parenthesis is waiting for me. I did this one, and this one's waiting for me. So now with this division sign, that means I can work with this. Okay. I'm going to do left to right. 3 plus 3 is 6, minus 2 is 4. Okay. So now we are still in PEMDAS, parentheses. I should do this one, but there's nothing to do. Inside this one is 8 minus 4, so I've got 4 divided by 4, which equals 1. Okay. All right. Let's go on to this one over here. Okay. Again, this one's evaluate the expression. Okay. We're going to substitute. Now here, it's real important that you understand the principle of substitution should always formally include parentheses, just like this. Okay, so B is 4, right? Then there's these parentheses, then the C. I'm going to substitute, so I'm going to put a 6, okay? But notice that this is the parentheses for my substitution. I need this one that was already there, the plus, and this A is going to get replaced with a 3. Replace, which is the same as substitution, okay? 3. Okay, that's my 3 being substituted, and then close it. I can open and close, good. Open, open, okay. There's a close. Here's an open and a close. Now, let's keep track of these, okay? So let's start on the inside. This one, open and close, done. Open and close, done. And this one over here, open and close. Okay? All right. So now I have to be careful, because if I use PEMDAS again, all right, we know we do parentheses, we go to the inside. So he's inside, there's nothing to do. He's inside, nothing to do, so now I go to this one. Okay, in here, I've got 6 plus 3. And I can carry out the multiplication. Now, some of you guys might notice that you don't need the parentheses here necessarily, but it's a good practice. It'll avoid problems in the future, okay? All right. Let's continue. I can simplify expressions. So here, let's go ahead and carry out the multiplication that's implied. Now PEMDAS would say to do the parentheses, but because of this p, I can't do anything. 8 plus 2p. Hey, I don't know what p is, so I have to leave it like this for now, okay? Next, I notice negative 7 here. What's happening? Again, invisible multiplication. So here, this is very important, okay? It multiplies here and over here, okay? The distributive property. So if you know it, great. If you don't, this is a good time to take some good notes, okay? So we have negative 56. Oops. All right. And we have minus 14p plus 2. Okay. So this negative 7 got multiplied in here like that. Now I've got this, this, and this. Again, parentheses, but there's nothing I can do. So now I can ignore the parentheses because PEMDAS says to do them, but there's nothing I can do. So now I look at it in this expression. This should be subtracted first. Again, I can't do it. Then I look at this, I can't do it, so I'm forced to deal with these two over here. Okay? So I can go negative 56 plus 2 minus 14p. And I've got negative 54 minus 14p. Okay? Alright, let's keep going. Okay, can we simplify with exponents? I'm very confident you are, so let's do this one real quick. This one, okay, I notice that it's the same base, 4, so that means I can take the exponents, which gives me that same base. 3 plus 3 is 6. Okay, now this is the wrong interpretation. Okay, do not allow yourself to do this. Okay, hey, it's the same base. Excuse me, 3 plus 3, okay, equals 4 to the 6. Alright, the property applies when these two same bases are being multiplied. Okay, you can combine their exponents. What else is the wrong interpretation? Okay, what if you have 4, 3 times 3, 3? Okay, I've seen students say different things, like they might say something like 12 to the third, maybe. That's wrong. What else? They might. I'm not sure. All right. I've seen different things, but the main thing is this property that we're talking about here, okay, that you're going to be practicing, is specifically for when you have the same base being multiplied. Okay. If not, right? If it's in this case, then guess what? All you would do is just do traditional math. 4 times 4 times 4, right? Which would be 64. 64. You would just do it this way, okay? Same thing with this case. If you're in this situation, mister, they're not the same base, but they're being multiplied, okay? Right? Since this is wrong right here, okay? Just do the basic math. This is 64 times 3 times 3 is 9 times 3 is 27. And then you can do it that way, okay? All that we're reminding you is that there's a special property that allows you to take a shortcut like this, okay? Again, so long as it's the same base, being multiplied. If not, just do the regular math. All right, next up, we have prime factorization, okay? 88, as soon as you guys see prime factorization, you think of the factor tree, okay? All you need to know is this is composite, okay? It's got factors that divided besides 1 and 88, right? If 88 was prime, only 1 and 88 would divide it. Composite means there's other numbers like 2 times 44, okay? Now remember, in this factor tree, you circle the prime numbers. And if you didn't circle this one, that means it's composite. It's got other factors like 2 times 22. Okay? I'm circling the prime. This one I don't circle it, which means it's composite. 2 times 11. This is prime factor. This is a prime factor. Now that I've got nothing but primes, I can list them. And these are the prime factors. Okay. All right. Let's go ahead and keep moving. So we have multiply fractions. Okay. So the cool thing about multiplying fractions is as long as you have two fractions written in simple form or improper form, okay, proper, improper, that's it. You just multiply the top. So let's have some fun and go like that. 3 times 7 is 21. 2 times 6 is 12. Okay. So we're basically done, but it all depends. You guys are lucky, right? It's multiple choice. So you guys can pick whatever. If it doesn't match, you keep going. Okay? One thing to remember is, like we've talked about so many times, this is division, right? So I can do some scratch work here. The top dot goes in the house. 12 goes into 21 one time. 1 times 12 is 12. And when I subtract it, I get 9. So that's where I get this whole number, because 12 went in one time for sure. 9 was left over when I divided by 12. Okay. Again, you could be done here. Look at the answer choices. You could be done here, but more often than not, fractions are always simplified further, right? So here we would realize that there's a common factor. Okay. And you actually look for the greatest common factor. The biggest number divides both of them. So, Mr. The 9 is 3 times 3. The 12 is 3 times 4, which means we can cancel this common factor, right? 3 divided by 3. So we get 1 3/4. Okay. We can continue practicing that if for some reason you struggle with that. Now, this one's very important. I can divide fractions. It's just as fun as this one, but it takes a little work. So pay attention. The first thing we do, okay, is we've got this set up. So again, we want at least to have this ratio of two numbers times a ratio of two numbers, okay? So it can be super easy. We have this situation, a whole number, a mixed fraction. So let's go and fix that real quick. Okay, we'll deal with the one in a bit. But this guy, you guys call it Texas Tornado. The main thing is you can take the 2 and multiply times the 6, which is 12, plus 1. Okay, so I think you guys have seen it like this. 12 plus 1 is 13 over 2. Okay, good. So I have my ratio, right? A number over a number. I don't have it here, but you guys can easily fix that because 1 divided by 1 is 1. And we have this. Okay. Now here comes, you guys call it the keep change flip. All you've got to do at this point is say, okay, division's kind of weird, so if you're able to turn it into multiplication, then you've got to flip this other fraction. Okay, so I guess they would call it keep change flip. Now we've done that and we have 2 over 13. Okay. Alright, so in tutoring I explained kind of what's happening here with the fact that this is a division problem with a division problem. It's pretty cool, but to keep the video a little shorter than it otherwise would be, let's go ahead and move on, okay? But we can talk about that either in classroom tutoring. Alright, I can write percents. So everyone loves these now. You guys are awesome at that. So, okay. But it's good that we have them set up this way, right? Because in class we've been working with percents turned into decimals. Now we've got the reverse, a decimal into a percent. So we do the bunny hops not to the left, but to the right. Okay, so we've got the 9%. Okay. And while we're here, don't forget that this percent really does mean that 9%. So when you have percent, you can either have it here or here, but this and this mean the same thing. That's the power of this discussion we had, okay? Alright. Let's go with I can solve with percents. Alright. What percent of 50 is 43? Now, a lot of students that we've already tried this with get it wrong, if not all of them. Okay, so because many of you guys, we talked about solve percent, right? Like 25% of 40. Okay. Now, that's good that you have that basic understanding, but you can't force things to be this way. If it is, beautiful. If it's not, okay, you've got to defer to your ability to turn algebra into English or English into algebra. So what percent, right, of 50? So that means we have something like this. What percent? So we'll just call it X. Some number, mister. I don't know what it is. Of multiplication 50.5 is 43. Okay. Here's that word is again. Being equal. Okay. What percent? You don't know what, so we can call this. We can call that X. This is multiplication. Alright. So, now how will we proceed from here in terms of getting our result? Alright, so once again we're in this situation, right? We've turned English to algebra. Now, just to be careful, we want to identify, hey, this is the center of the equation, or if it was an inequality, the whole thing would be an inequality. Here's the center of this, is the left side, here's the right side. What operation? Multiplication, so I'm going to divide by 50.5. Why am I looking on this side? Some people might say, why don't I subtract 43? You want the variable by itself, right? When it comes to solve. So I need to cancel this with the, because it's with the variable, okay? So I get X equals, I got something like 0.8514. Alright. Now they say what percent, so the symbol means pretty close to, okay? I'm going to bunny hop 1, 2 to turn this decimal to a percent and say 85.1%. Okay, this one, if it takes you some note taking and some multiple attempts, okay, this is where you spend some time, okay? Alright. Now we come over here to this one. Original price of a kitten is $199 with 50 cents. So these require some thinking, okay? And the discount is 30%. Original price. So here's kind of what we got to talk about is they want the original price. So you've got 30%. This is the discount, okay? And then over here you have the 70%, okay? This 70% is really what you pay. This is what you don't. What you don't pay, okay? So just take some time to think, hey, a discount, they took that away, 70%. So I'm describing it this way to avoid it looking more complicated. But again, it just depends kind of where you're at, okay? But this should be simple to understand. Hey, okay, I get it. I don't pay the discount. The other 70%, since all of it is 100%, is what I do pay. So let's go ahead and multiply that times 70. Now, we've talked about how actually doing math with percents isn't helpful, so we replace it with a decimal, right? We go 1, 2 bunny hops this way to accomplish that mission. Okay. Now, the other version, okay, I would recommend you guys really think about this because it should make it a lot easier. Okay, do they want to know what's the discounted price? And you would multiply this times the 30. Or do they want to know what you're actually paying after the discount? Okay. All right, we're gonna leave it like that. Again, there's a lot going on in this video, so if you've got questions, we'll deal with it in class. This next one, okay, I can multiply mixed numbers. So we've been in this situation before, okay, a little different. This was a little more intense, but luckily it's multiplication, so let's keep it simple. Let's Texas tornado this bad boy. Okay, so it's a negative. Here we have 6 plus 1 is 7. Here we have a negative also. 10 plus 2 is 12. So negative times a negative, right? Our Dorito is going to tell us it's positive. 84 over 10. You guys can divide it out. The top dog inside. 10 goes in here 8 times. There's 4 left over after dividing by 10. And you gotta love this, right? 2 divides 4, 2 divides 10. So once we take out the 2, we get 2 over 5. Okay? Alright. Next, I can divide mixed numbers. It should be the same with that little trick in the middle, right? Keep, change, flip. So let's go ahead and Texas tornado this bad boy. 54, 61. I won't do too much too fast. 21, 27. Okay. Now we can keep, change, flip. Right. Change it to multiplication. Flip. And we've got this one should be some fun here. We know definitely one's going to go in there. Okay, and upon verifying, we got 184, 243. This one's dirty because it looks like you might be able to factor something else out there. Hopefully it doesn't get, I don't think they would do you guys too dirty out there, okay? So anyways, as long as you have the skills, you're good, okay? Alright. I can multiply integers. So this one, really there's nothing difficult. I know you guys can multiply too easy. The main thing is keeping track of those negatives and positives. So on a Dorito, a positive times a negative is negative. Okay, so we'll leave that one alone. I can divide integers. Same thing here. A positive divided by a negative is negative. Okay, and you guys, I trust, can divide that. So we'll move on. And down here, I can multiply decimals. So, right, most of you guys are strong. Some of you guys need just a little more practice. So take this very serious. Right, you can go and carry out the multiplication. We got 3, 6, 14, 3, 5, 6, 1. And then, of course, like we have in our notes, you count the bunny hops, right? We ignored first the decimals here, but now we got to take account. Mister, it wasn't there. It's 1 bunny hop there, 1 bunny hop there. We move it 2 bunny hops, so we get, alright. And let's cover the last 5. I can divide decimals, okay? Alright, so in this case, this can get pretty serious and intense, so I'm going to offer it 2 ways, okay? Depending on what you're comfortable. You guys can look at this as negative 22, right? Tenths divided by 5 tenths. Okay? This is if you like the keep, change, flip, it's ready to go. The other option, if you guys followed along with that whole process of moving the decimal here and here, okay, you can set it up where it's negative 22 divided by 5, okay? So this we've already covered. It's going to take care of this one. We've got this situation now. So it doesn't cause any confusion. Off the bat, you got to recognize from your Dorito, this is a negative divided by a positive, which will give us a negative answer, okay? Now all you have to do is divide these numbers the way you guys know how to do. 4, 22, right? Since there's a remainder, 22 is the same as 22.0. I can bring this guy down. 5 goes into 24 times. This decimal comes up here. 4 times 5 is 20. Okay, so we're in this situation. We get the answer right there. Notice, to avoid problems, you identify what sign it's going to end up having. Okay, and you carry out the multiplication. Here, I can add and subtract any kind of number. There's a lot going on here, so let's just set it up for you guys. Okay, so here I would have negative 8 minus, okay, 0.3. I'm sure you guys did this in elementary school where you have to line up the place values. So here's the setup for that. Okay. Now, in this case, this is actually pretty easy. I think setting it up is where there could be drama. So don't forget that this situation, we have a negative minus this number, which actually can be tough for some of you guys, can be rewritten as, okay, this is another one for you to have in your notes to think about, as plus negative 0.383. Okay, so these are really good. This one's another good, we can start this one to have in your notes. Okay, so it's, alright, here we have this situation where we have to add these fractions. They look harmless, but it's not multiplication. Okay, so in this case, this is actually adding fractions is tougher than multiplying them. Okay, just accept the fact. So, alright, but it's not that difficult. It's actually kind of fun because you need to identify the least common multiple, right? Or the least common denominator. So, the easy trick is just to multiply them. 5 times 3 is 15, okay? But you might want to create a list. So you're like 5, 10, 15, 20, and then 3, 6, 9, 12, 15. Once you find a match, okay, by coming up with a list of multiples, that will be your common denominator. Okay, so let me get rid of some of this stuff here. So in this case, we'd have 15. It's a negative. Okay. And we'd have a 15. That's what we just agreed upon, right? The 15. But this one needs to be multiplied by 3 to get the 15. So I need to do the same thing to the top. This one needs to be multiplied by 5. I must do the same thing to the top. 5 times 2 is 10. And now that I have this, it becomes a piece of cake, right? Negative 12 plus 10 is negative 2 with the 15. Though you don't do nothing with the bottom. You already did the work, okay? So again, this one I think is worth reviewing for some of you guys. So put a star on that one, okay? Here we go again. Alright, I'm not going to do this one. It's pretty much the same scenario, okay? Let's see here. Yeah, you guys are good there. And this last one is pretty simple. I guess what we can do for this one is just kind of review the whole number line concept where you've got 0. Okay, this tells you to go left 8, right? 1, 2, 3, 4, 5, 6, 7, 8. This add 3 tells you to go 3 bunny hops this way, right? 1, 2, 3. So negative 5. Okay. I think that is a good refresher. Alright guys, appreciate your time. We'll catch you on the next one.